Good morning, guys. Today we are going to solve another problem on the DP series of Geek4Geeks POTD challenge. So today's problem is minimum cost to fill the given weight in a bag. Okay, so the question is like this: that you will be given an array of cost of positive integers of size n and integer w, where cost of I represents the cost of an I kg packet of oranges, and the task is to find the minimum cost to buy exactly w kgs of oranges. The cost has a one based indexing. If buying of exactly w kg oranges is impossible, then return -1. Okay, so what you can see is what I can write it over here is I can write it over here as the cost of say buying the oranges. Okay, so we have to first take into account that cost array has some particular cost. Okay, so I will be having a cost array. And there will be some elements in the cost array. So what are those elements? 20, 10, 4, 5 and 100. So suppose the elements are 20, 10, 4, 5 and 100. Okay. Next is I will be given a given weight and a given size n. Okay. So I have to take the weight of the oranges as weight equals to 5 kgs. Okay. So this is given by the user. N equals to number of oranges, which is also, you can see over here, there are 5 oranges. Okay. Now I have to find the minimum weight. What is the question is like, we have to find the minimum cost to fill the given weight in a bag. So the thing is, suppose this is a bag, and there will be like the weight of the bag should be 5 kgs, and the minimum cost to fill all the oranges inside the bags. So that I have to find minimum cost to fill. Okay. So what are the possible way I can do it? I can see if I purchase 2 kg packet, 3 kg packet and 5 kg packet for 4 coins. 2 kg 10, 3 packets 3 kg for 4 and 5 kg for 14 coins. Okay. So what I can do basically is first I have to check the given weight. So given weight equals to 5 kg. In how many possibilities you can write this 5 kgs? So you can write this 5 kgs as 2 plus 3, or you can write the 5 kgs as 1 plus 2 plus 3 plus 4 plus 5. Okay. No, sorry. You can write the 5 kgs as 1 plus 4. Okay. Or you can write it like 5 plus 0. 4 possibilities. In what other way you can write 5? Say 1 plus 2 you can't do. 2 plus 3 already done. 5 plus 0 done. 1 plus 4 is 5. That also done. I guess now let's check the possibilities of the sum. So whenever it is 1 plus 4, then the cost is, for the first kg of the apple is 20, and the fourth item is 1, 2, 3, 4 is 5. So the cost will come as 25 over here. When the 2 plus 3 is there, so 2 is this, 3 is there, so the cost is 14. When the next is 5 plus 0, so when the cost is 5 plus 0, when the weight is 5 plus 0, the cost comes to be as 100. But all of this has a weight of 5 kgs. So which is the lowest among these particular elements? Obviously 14. So minimum cost in such a way that it is lowest. So 14 is the answer. Okay. So also let's check some of the constraints. So I will write it over here, the constraints. So what are the constraints of this particular problem? The constraint is the cost of I minus 1 means I kg of oranges unavailable. So if the cost of array of I is equals to minus of 1, so what I will write? It means orange is unavailable. Okay. Let's check the second example. It may be assumed that there is an infinite supply of available packet types. Okay. So there may be infinite supply of packets. So let's solve this particular problem of the today's POTD challenge. So first I can see a minimum cost. So over here I'm going to create a DP array and DP equals to new int n plus 1. Okay, once that is done, now I will take an infinity variable inf equals to integer dot max underscore value, integer dot max underscore value by 2. Okay, for I can write it like this: int I equals to 0, I less than equals to n plus plus. Over here what I can do is dp of I equals to inf. Once the for loop run, I can set the dp table as 0 for the initial values. Now I'm going to form the table with the possible values plus plus. Now I'm going to check of the unavailable condition. So if the cost of I, okay, minus 1 not equals to minus 1, then I will traverse through the table j equals to I, j equals to n, j plus plus. I can write dp of j equals to math dot min of dp of j minus I plus. What I can do next is I've taken the jth element and the j minus I element. I can cost optimize it by cost of I minus 1. Finally, after this I can return the dp of the weights equals to inf, which is that variable we have declared over here, inf minus 1 dp of w. So we can try to compile this code, w plus 1. So let's check this. I guess yeah, we've successfully completed today's problem statement. We are looking forward for new problem. Thank you.